Pluto, once considered the ninth planet of our solar system, is a distant and dim celestial body now classified as a dwarf planet. Despite its small size and remote location, Pluto is once again at the center of cosmic discussions. Thanks to recent startling claims from renowned astrophysicists Neil deGrasse Tyson and Michio Kaku. According to them, Pluto may be on a potential collision course with Neptune, and this is a mere speculation. They're issuing a serious warning. Could this tiny, icy world really be heading for a catastrophic impact with a gas giant? How could such a collision even occur? And if it did, what consequences might ripple through the solar system, possibly even reaching Earth? Is this just a bizarre optical illusion born of celestial mechanics, or is something far more real and terrifying unfolding in space? Pluto's orbit brings it alarmingly close to Neptune's path. Tyson and Kaku caution that even a slight shift in this intricate dance could trigger a disastrous planetary encounter. Could this spell danger for Earth as well? And more crucially, how is such an event even physically possible? Join us as we dive deep into the cosmic implications of a Pluto-Neptune collision. Pluto remains a subject of fascination in the vast theater of the cosmos. Though reclassified, it continues to surprise us. According to leading experts, its path around the Sun takes a staggering 248 Earth years to complete, a journey so long that Pluto hasn't even finished one full orbit since its discovery in 1930. But what truly makes Pluto's orbit stand out is its eccentricity. Unlike the almost circular paths of the major planets, Pluto's trajectory is highly elongated and tilted at an angle of 17 degrees to the solar plane. This offbeat path makes it unique and possibly dangerous. One of the most puzzling and intriguing aspects of Pluto's orbit is its overlap with Neptune's. For about 20 years during each orbital cycle, Pluto is actually closer to the Sun than Neptune. So, why haven't the two collided already? The answer lies in the subtle interplay of gravitational forces. Since its discovery, astronomers have worked to decode Pluto's strange orbit. While most planets orbit neatly within the same flat plane, Pluto's tilted, off-center paths stand out sharply. The mystery deepened with the realization that Pluto's orbit truly crosses Neptune's. Yet they've never collided, a fact that serves as a testament to the delicate precision of cosmic physics. This is where the three-body problem comes into play, a notoriously complex celestial puzzle involving the gravitational interactions of three bodies. In this case, Pluto, Neptune, and the Sun. Their mutual gravitational pulls create an intricate system where motion is tightly interdependent. Key concepts like asynchronous oscillation, orbital drift, and the VZK wobble help explain why a collision hasn't occurred yet. Asynchronous oscillation ensures that when Pluto passes through the area of Neptune's orbit, it remains at least 90 degrees away in angular distance. This separation helps prevent direct impact. Orbital drift refers to the vertical movement of a body during orbit. For Pluto, this means that even when it's closest to Neptune, it lies significantly above or below Neptune's orbital path, providing another layer of cosmic protection. Crashes in the VZK wobble, understanding Pluto's strange yet stable path. Another major factor in the conversation about potential space collisions is the VZK wobble, named after researchers Zell, Kai, and Kaku, who studied the gravitational dynamics between celestial bodies. This concept refers to how the gravitational pull between three masses, like Pluto, Neptune, and the Sun, interacts to shape their movements. In Pluto's case, this wobble helps explain why its orbit near the Sun appears so unpredictable. Despite seeming chaotic, the VZK wobble actually contributes to Pluto's long-term orbital stability. It shows that even in a seemingly disordered cosmos, certain patterns and principles enforce balance. This tri-body interaction is key to understanding how gravitational forces affect the paths of celestial objects. Studying these forces helps scientists better grasp the behavior of not just Pluto, but other planetary systems and distant galaxies too. In the late 1980s, numerical simulations revealed that while Pluto's orbit benefits from stabilizing mechanisms, it is still sensitive to small changes. Even tiny differences in its starting position or velocity can cause dramatic changes in its path over centuries. Still, data has shown that Pluto's trajectory remains steady over incredibly long timescales. Automated readings and simulations have deepened our understanding of how giant planets like Neptune, Jupiter, and Saturn influence Pluto's movement. Neptune, in particular, shares a unique orbital resonance with Pluto. For every 2 orbits Pluto makes, Neptune completes 3. This synchronized dance helps maintain stability. But Neptune isn't acting alone. Jupiter's massive gravitational force also plays a key role in keeping Pluto's orbit aligned, with Saturn adding to this gravitational balancing act. Together, these giants work in harmony to ensure Pluto doesn't veer off course or collide with other objects. Without such intricate gravitational mechanics, our solar system would be far more chaotic. Bodies like Pluto might be knocked off track, collide with others, or even be ejected entirely, setting off chain reactions. Understanding Pluto's motion is especially important given concerns about its future interactions with Neptune. It gives us a deeper look into the dynamic, ever-shifting nature of our solar neighborhood. Pluto is a powerful example of how even orbits that appear erratic can find long-term stability through complex gravitational interactions. This also highlights the need for ongoing monitoring and analysis of such unusual cases to better understand our place in the universe. Exploring distant regions of space constantly brings us face-to-face with strange behaviors, Pluto's orbit being a prime example of orbital irregularity. The concept of orbital chaos, where even slight changes in initial conditions lead to vastly different outcomes, is evident here. With the help of computer simulations, scientists can model how Pluto and its neighboring planets interact. By tweaking small variables in these simulations, they can see how subtle changes might drastically alter Pluto's future. These models from the 1980s revealed something surprising. Despite stabilizing features like asynchronous oscillations and orbital drift, Pluto's path can still behave unpredictably. Even the slightest deviation in Pluto's position or speed could, over time, lead to a vastly different orbit. Yet, despite all this uncertainty, Pluto's path has remained consistent for billions of years, a testament to the hidden order behind what first appears chaotic. Studying orbits like Pluto shows just how complex and finely balanced the cosmos really is. Predicting the distant future of cosmic systems remains an extraordinary challenge. The inherent unpredictability of these systems makes long-term forecasts riddled with uncertainties. While mathematical models excel at deciphering and estimating celestial motion, they also expose the limits of our knowledge. These equations rely heavily on initial conditions, meaning even the slightest error or variation can lead to drastically different outcomes, making exact predictions nearly impossible. Beyond the unpredictable nature of planetary paths, Pluto serves as a vivid reminder of the universe's constant change and dynamism. Despite all that humanity has learned about the cosmos, Pluto's anomalies remind us of how much still remains hidden. Studying how massive planets influence Pluto's orbit broadens our understanding of the solar system's intricate choreography. It reveals how each planet's position and presence can profoundly affect the stability and motion of others. So, why are leading astrophysicists sounding alarms about a potential collision between Pluto and Neptune? Even though the laws of celestial mechanics are designed to prevent such disasters? Neil deGrasse Tyson, a renowned astrophysicist and a prominent advocate for science communication, offers a unique perspective on this cosmic conundrum. Best known for his role in reclassifying Pluto as a dwarf planet, Tyson brings thoughtful insight into the evolving science of orbital mechanics. He views Pluto's reclassification not as a demotion, but as a reflection of our growing understanding of the solar system's complexity. To Tyson, the erratic nature of Pluto's orbit illustrates the ongoing need for scientific curiosity and adaptability. He sees Pluto's strange path as a symbol of the mysteries that still surround us. While Tyson generally maintains an optimistic view of astronomy's potential, his concerns about a Pluto-Neptune collision reflect a more sobering outlook. His apprehension is rooted in the recognition that even small, cumulative changes in orbital paths can eventually lead to catastrophic outcomes. Pluto's trajectory, particularly the area where it overlaps with Neptune's orbit, creates a delicate gravitational dance. Tyson warns that this synchronization may not last forever. Even the tiniest disruption in Pluto's path could, over millennia, spiral into chaos. Although such an event lies far beyond any near-future timeline, likely unfolding over timescales that dwarf human civilization, Tyson's cautious tone emphasizes a need for vigilance and deeper investigation. He's not alone in raising these concerns. Michio Kaku, a celebrated theoretical physicist, also acknowledges the fragile balance that governs planetary orbits. Like Tyson, Kaku is captivated by the vastness of the cosmos, but he also warns of the unpredictable consequences that can emerge from even subtle interplanetary shifts. Both Tyson and Kaku underscore the critical importance of continued space research to uncover the unseen forces shaping planetary motion. Pluto's situation is a striking example of how scientific understanding is always evolving. Every discovery brings new questions. As space science advances, the remote possibility of a Pluto-Neptune collision serves as a humbling reminder. The universe is full of surprises. Even seemingly stable orbits can change in profound and unexpected ways. In the end, Pluto teaches us not just about celestial mechanics, but about the spirit of exploration itself. Its strange journey across the solar system reminds us to keep looking up, stay curious, and never stop questioning what lies beyond.